It has been a week since Krea 2, a text-to-image model, was released, and I've often seen people trying to use it in an image-to-image workflow. But you can't turn Krea 2 into a true image editing model just by adding a ComfyUI node. The model's architecture simply doesn't have the pathway required to preserve and modify an existing image. So no matter what wrapper you build around it, it won't function as a real image editing model. This video is for beginners, and we'll look at a few examples of using Krea 2 in an image-to-image workflow to understand what it can actually do and what the best possible results look like. This is the basic text-to-image workflow. The default prompt generates an image that isn't really suitable for a YouTube tutorial. This one looks much better. I will use the same image as an example. Now here's a simple image-to-image workflow for the turbo model. Instead of feeding an empty latent into the K-sampler, I first encode the input image using the VAE and then pass that encoded latent to the K-sampler as the latent image. My prompt is simple. She is cooking in the kitchen, anime movie style. The generated image shows a woman cooking in an anime style. However, the character looks different because the model has complete freedom to modify the input latent image. This freedom is controlled by the denoising value. Lowering the denoising value limits how much the model can alter the image, making the result closer to the original input. Even then, our character still isn't actually cooking. I tried a few more times with different seed values, and eventually I got a result that was much closer to what I described in the prompt. There are still noticeable differences, but this is about the best you can achieve with this technique. You can also experiment with different styles, such as this stencil style or this papercraft style. From my testing, the denoising value that works best is between 0.6 and 0.8. Going above 0.8 usually causes the result to drift too far from the original image. Another image-to-image trick I found online uses the Qwen-Image Edit Plus node. You can either use the input image encoded as a latent or simply provide an empty latent. In this workflow, the input image is connected to the Edit Plus node along with the VAE. This means the image is first encoded and then used to influence the generation process by acting as an additional conditioning input alongside the text prompt. I'll use the same prompt and run the workflow. The generated image is almost identical to the input image. In this case, the generation is heavily constrained by the reference image. It's actually better to provide an empty latent and let the model generate freely while keeping the denoising value at 1.0. With this approach, I get a slight papercraft effect along with a few other changes. Notice that I never asked the character to put her finger near her chin, yet that detail was carried over from the reference image. On the other hand, I did ask for a papercraft style in the prompt, but it only had a subtle influence. Now, if I replace the reference image with the papercraft style image that I generated earlier and remove the papercraft style part from the prompt, the output changes significantly. The difference is much larger, and the finger near the chin pose is no longer present. By looking at this workflow, we can see that the prompt, the reference image, and the VAE encoded latent are all sent to the K-sampler. However, Krea 2 completely ignores the VAE latent. Krea's DIT only accepts the text tokens and the noisy image patches. The noisy image patches can come from either the encoded image or an empty latent, depending on the workflow. There is no pathway for a reference latent, so even if a node outputs a reference latent, Krea simply ignores it because the model was never designed to perform image editing. We did observe the effect of providing a reference image, but we should also look at the model loaded by the SLIP loader. The file being loaded is actually a vision language model, VLM. The reference image is passed through the VLM, which generates a description similar to this: portrait of an anime schoolgirl with long dark hair, wearing a white shirt, a dark blue dress, and a red ribbon, touching her lips with one finger against a simple white background. This generated description is then combined with your text prompt. So the process works something like this. The reference image is analyzed by the vision language model, which produces a text description. That description is combined with your prompt, and Krea 2 then generates an entirely new image. That's why my prompt asking for a papercraft style had less influence than the VLM's description mentioning touching her lips with one finger. The model is following the combined text description rather than editing the original image. In this workflow, the VAE isn't responsible for preserving the reference image. It doesn't contribute to the image editing behavior, and its presence can give the misleading impression that Krea 2 is performing true image-to-image editing when it actually isn't. I came across a couple of custom nodes that are designed to address this limitation. Instead of trying to perform true image editing, they make better use of the vision language model by converting the reference image into text-like conditioning. This allows Krea 2 to generate a new image that is inspired by the reference rather than directly editing it. I installed both custom nodes using the git clone command to see how well they work. I'll replace the Qwen Edit Plus node with the Krea 2 text encoder node. There's also an option to provide a mask, which we'll look at later in the video. Now I'll use the same prompt and see what result we get. The generated image is quite similar to the previous result, and the reason could be this vision megapixels setting. The vision megapixels value limits the size of the input image before it's passed to the vision language model for image description. When the input image is large, it dominates the text conditioning. Internally, the VLM may generate a very detailed description of the image, in comparison to my prompt shown below. Because the visual description is so rich, it can easily overpower the text prompt. I'll reduce the vision megapixels value as much as possible and run the workflow again. Now the generated image is much more acceptable. We'll come back to the mask padding option later in the video. Below that is the vision position setting. This controls how the original prompt and the VLM-generated description are arranged before being sent to the model. The last option is about printing the prompt into the program's console, which is useful for debugging and shouldn't affect the generation process. The vision position setting, however, has a noticeable impact on the generated image, so I recommend trying both options to see which one works better for your use case. Now let's take a quick look at the mask feature. I'll select only the character's face. This should allow the vision language model to extract details about the subject, such as the fact that it's an anime character with dark hair who is touching her lips with one finger. I'll save the mask, add the preview mask node, connect everything, and run the workflow. The newly generated image is based on the information extracted from the selected region. So this isn't in-painting. It's simply using the masked area as the source of visual information for the vision language model. If I increase the mask padding value, the area around the mask is also included, allowing the vision language model to extract more information about the subject. A padding value of 0.30 was too large, so I experimented with a few different values. At 0.07, the model is able to capture details like the red ribbon and the dark blue school uniform. There's also an optional node that can be used with the Krea 2 text encoder. This node lets you provide your own instruction, overriding the default instruction that's sent to the vision language model. The second custom node I mentioned earlier is conditioning Rebalance. You can download the workflow directly from its repository. This is the same workflow you just saw. It looks a little different because I've opened the subgraph. I tested it with 3 reference images, and in my experience, using 2 images produced better results. I also added a background removal node because the other reference image has a plain white background. The character's identity still won't remain perfectly consistent, but if you describe the body and clothing clearly in the text prompt, those attributes can be preserved much more reliably. Overall, this node did a good job of preserving the character's identity. I'd estimate it was around 75% consistent with the reference. Now let's look at what else can be done to gain more control over this text-to-image model. The current pipeline works roughly like this. The prompt is processed by the Qwen-3VL text encoder, which produces the text embeddings. Those embeddings are then passed to the DIT denoiser, which generates the final image. Another possibility is to provide an additional conditioning signal during every denoising step. For example, instead of only guiding the model with the prompt, a woman wearing a red jacket, we could also provide a ControlNet that says, follow this pose, or use this DW pose. Now the question is, can Krea 2 use a ControlNet? In principle, yes, but only if a ControlNet were trained specifically for Krea 2. If such a model were developed, it would also need to be integrated into Krea 2's inference pipeline. During sampling, the DIT denoiser would have to consume the ControlNet features at every denoising step, allowing the additional conditioning to guide the image generation throughout the entire process. The workflow we're using for the Krea 2 model uses the Qwen-Image VAE for encoding and decoding, and Qwen has released multiple ControlNet models in the past, so I decided to try a few of the workflows available in the ComfyUI templates. This Qwen-Image InstantX ControlNet union supports several conditioning types, including depth map, DW pose, canny edge, and a few others. Let's try adding it on top of the default Krea 2 workflow. I'll organize the nodes first and then run the workflow. This is where the ControlNet is inserted into the pipeline. It becomes an additional conditioning input after the positive and negative prompt conditioning. On the left, the InstantX ControlNet Safe Tensors model is loaded, along with the Qwen-Image VAE, which is used to encode the DW pose input. I'm also using the 4-step Lightning LoRa, which speeds up image generation considerably. The generated image is larger than 1024 pixels, but that's not a problem because Krea 2 can handle resolutions higher than 1024 pixels. To keep it simple, I'll use the same default prompt provided in the template for both workflows. Now I'll replace the standard K-sampler with the K-sampler advanced node, which we previously used with the WAN video models. The idea is to split the total inference steps between the two workflows. I'll let the Qwen workflow perform the first few denoising steps, and then pass the partially denoised latent image to the Krea 2 workflow to finish the generation. Krea 2 normally uses 8 inference steps, so I'll stop the Qwen workflow after 2 steps. I'll make the connections quickly and preview the partially denoised latent after those 2 steps. That same latent will then be passed to the workflow below. Krea 2 will perform the remaining inference steps, and once the denoising is complete, the final latent will be decoded in the second workflow. That's all there is to it. First, I'll run the Qwen workflow for 2 steps, and this is the result. In the second workflow, the total number of steps is still 8. The K-sampler advanced begins from step 2 and continues until all 8 steps are completed. That means Krea 2 is now performing the remaining 6 denoising steps, and this is the final result. The character is still pointing her finger at her lips, but overall, the result is somewhat acceptable. Next, I downloaded a different pose from the internet and tried the workflow again. The image generated by Krea 2 didn't follow the pose very well. I'll increase the number of inference steps performed by the Qwen model to 3, leaving the remaining 5 steps for Krea 2. It looks like the additional Qwen step pushed the generation closer to the desired pose. But Krea 2 still insisted on bringing back the finger-pointing pose from its own interpretation. I decided to replace the Krea 2 text encoder with the conditioning rebalance node because, as we saw earlier, it offers a few advantages. I also wrote a more detailed prompt describing our subject while keeping the image token value low. I'll make the connections quickly and then run the workflow. The generated image is much closer to what I expected, and I think the result is quite acceptable. With this type of workflow, the character's body pose becomes much easier to control, provided you describe it clearly in the prompt. This approach lets you take advantage of Krea 2's image quality, but maintaining a consistent character from a single reference image still doesn't seem possible unless you use a character LoRa. You can also use the Qwen-Image Edit Plus text encoder in the first workflow to combine the character's identity and the desired pose. Then, pass the partially denoised latent into the second workflow so Krea 2 can preserve the lighting, composition, and overall visual quality while completing the generation. So, that's it for this video. Let me know in the comments if you found this video interesting or informative. If you have any questions or if you've discovered a better workflow, I'd love to hear about it. You'll find all of the workflows used in this video in the description below. Thanks for watching, and I wish you an excellent day.